Alright, got a Lexus in the shop today. The owner thinks it needs a new alternator. Let's see what's going on and see if they're right. Okay, as you can see, that's the vehicle we're going to be working on, a 2006 Lexus RX330, which is a Toyota. But anyway, the background on this vehicle is several months ago, they were not driving the vehicle very much. In fact, even today they don't drive the vehicle very much, and when they do, it's very short trips. But they weren't driving the vehicle hardly at all. Then they went out a couple different times, and tried to start it, and it was a no crank, no start. And it was diagnosed due to dead battery, most likely just from sitting around. These modules will stay alive and use up a little bit of power as they're just when the vehicle's sitting, and so it's not uncommon. If you let this thing sit a week or a couple weeks without starting it, you could come out to a dead battery. So the battery was replaced. Now fast forward to today, and evidently they went out and the vehicle started fine, and then they drove it to their destination, and then when they came back out, tried to start it, it was a no crank, no start. They called roadside assistance. Roadside assistance came out, put a jump pack on there and got it started. They told the owner that they needed a new alternator. So that's where we're at. So now we need to go and see if that is really the case. And the owner also admitted to me, after a little bit of questioning, that they inadvertently left this mirror open, which left the light on right before this happened. So that's definitely a big clue right there. Now, I was able to start this thing up, drive it into the shop. So right now, it didn't give me a no start where I needed a jump pack to get this thing in here. So we'll do some basic checks. We'll grab the voltmeter and we'll do some basic checks just right on the battery right now. Now, evidently, the owner, actually right after roadside assistance told them they needed an alternator, they called Lexus and tried to make an appointment to get a new alternator put in, but Lexus didn't have time. So then they called me and asked me if I could look at it, and so I said yes. So before we grab the voltmeter, let's look at the battery. You can see this was installed this year. So this battery is new, and just looking at it, I don't see any evidence of any leaks. Corrosion, no, it doesn't have any evidence of any corrosion anywhere. It's not bulging. Sometimes the sides will bulge out or the top will bulge out if there's any issues. No, this thing still looks brand new, so at least upon initial inspection that looks good. Alright, now all I'm going to do is take my voltmeter here. I'm going to switch it to volts DC because we're measuring direct current. This is a 12 volt system, and I'm going to take and touch one lead to negative, one lead to positive. That's all I'm going to do. We're going to see the voltage. Now, although I'm using an expensive Fluke model, we could easily use this cheap Harbor Freight one. They used to give these away free. In fact, I got this free, and I just keep it here as a prop. So every once in a while when I'm talking about voltmeters, we could easily use this cheapo one here. But as soon as I paid for this one, we're going to use this. Alright, hopefully you can see it. I got it set to volts DC like I said. I'm just going to go right to the middle of the battery post on each one. You can see we're at 12.5. Now that's an unloaded test. We don't have a load on the system right now. And what I also like to do is I want to go around in different areas on this battery cable and make sure our voltage looks the same or very, very similar. We don't want to have a voltage drop between the battery post itself and the connection or the wiring. And so you can see no matter where I go, we're at about 12.5. Now that's an unloaded test. Let's turn on the headlights. We'll turn them on high and we'll see what our voltage looks like after that. Alright, I got the high beams on, and now we'll see what the voltage is right on the battery post, and you can see we dropped to 12. Let me make sure. That was at the post, and on the connector itself it looks like we're the same everywhere. So we don't have a voltage drop, it doesn't look like, between the post and the battery terminals, which is good. We always want to make sure we have a good connection, and we want to make sure these things are solid, not loose, and they're tight and solid. So yeah, we dropped about a half a volt just by turning the lights on and getting the load on there. And I always like to test, electrical circuits with a load if at all possible. So that's definitely low. We're definitely showing low voltage, lower than we should be. Let's start this, and we'll do a quick check for the alternator output. So as you heard, it started no problem. Alright, we'll do the same test. I moved this so it wouldn't fall. We'll do the same test now at an idle and see what our voltage is. We want it to be at least above 13. I believe Toyota specs say at least above 13.2 to 14.8. Anywhere roughly around 14 is where we want it, give or take a little bit. So right on the battery posts, we're at 13.6 at an idle with no loads. And we'll just make sure we don't have a voltage drop anywhere on our connections. You can see it doesn't matter where I touch, we're at around 13.6 volts. So 13.6 is making it all the way back to our battery cables or terminals right here, the posts. Let's see what it looks like with a load on it. Alright, I got the headlights on high and I have the blower motor on high. So we're putting a heavy load on this alternator right now, especially with our discharged battery at only 12 volts. So let's see what we're outputting now at an idle. 13.45, 0.46. That's just fine at an idle. It would be nice if it was a little bit higher, but at an idle that's fine. Toyota specs actually say it needs to be above 13.2 at 2,000 RPMs. And I'm sure if we raised it higher, or raised our RPMs up to 2,000, it would be higher than that. They don't have an assistant today, so it's kind of hard for me to do that. But I have no issues where it is right now. Alright, so with a visual inspection and a couple simple checks with a voltmeter, it looks like we have a discharged battery. It's just low and needs to be recharged just based on what we can see and what our voltages were. And then as far as the starting, the starter sounded just fine. And the alternator looked like it was putting out exactly where it should be, especially for an idle with loads. That was no problem. I have no issues with it. So now that we did that, let's put our battery tester on there. So we'll get a little fancier. We were keeping it simple there for a little bit. Now we'll put our tester on there. We're just going to put, positive and negative, and that should fire our tester up. You can see this is from Foxwell. So it shows that we're at 12.5. So I'm going to turn the headlights on for about 20 or 30 seconds and get rid of the surface charge. I know there's a surface charge on there from us running the engine, and it looked like the alternator was putting out. So we're going to get rid of that surface charge so that our tests are good. Alright, now that we dissipated hopefully we dissipated any surface charge, let's go ahead and test our battery. Hopefully you can see this. 12 volts, we're going to do it in the vehicle. It's a top post battery. This is a regular battery. It's not AGM or gel. We're going to do cold cranking amps, or CCA, and we get this number or stat right off the battery. So our CCA is 700 cold cranking amps. So this is where we add it in. 700. Now it'll test it. And our cold cranking amps are measured at 692, just a hair below it. And get back there. It says good, but it recharged, which is exactly what we thought. This will also allow us to do a starter and alternator check. You know what? I'll do it real quick, and I'll come back and I'll show you what the results were. Alright, I'm done charging. You can see here's our results. I already showed you that. It says that the battery's good, wants us to recharge it, measured at 12.33, and just a little bit less than our rated cold cranking amps. And we go to the second page for the battery. There's our state of health, our state of charge, and I don't remember what that is. Somebody help me out. I can't remember what that is off the top of my head. And then if we go to cranking, you can see our cranking was normal, but we do drop down to 11.0 volts, and that's not out of the ordinary. And we go to our charging, and just like we thought before, no problems. There's our load, and then there's our there's our no load, and then there's our load. So these numbers pretty much match what we did with the voltmeter. We didn't even need the fancy tool, although it helps us out. This battery needs to be recharged. Okay, so now we know our charging and starting appears to be okay. It's just a dead battery, or battery lower than where it should be. It's not completely dead right now. So what can cause that? What are some issues? One is leaving something on, and I did talk to the owner and they admitted that they left this mirror on, and so that will definitely kill your battery. So we need to make sure accessories like that are turned off, otherwise you're going to come back to a dead battery. And so I think that's what happened on this last one, is they did that. Another reason can be like what's also going on with this vehicle, very short trips and very intermittent on those trips, and so it's not giving enough time for that alternator to charge the battery back up to a full state. I think that's what's going on with this car. Now there's also could be a parasitic draw, where we have something still awake on the vehicle that's draining the battery, similar to what, you know, leaving a light on would do. Now I am a little concerned that although that little Sirius XM radio attachment right there is off right now, I did notice that after I turned it off and powered everything down, that stayed on for quite a long time. That could be an issue right there. There are tons of control modules on these vehicles, and it's possible that either a component or a control module is staying alive, and it's enough to drain our battery also. And that happens quite a bit on these newer, more modern vehicles. But I think in this case it's simply that the owner doesn't drive it enough and they left the mirror on. Alright, one last check I want to do. I want to make sure this thing does not have a parasitic draw, because this battery has been dead a couple times, and so we want to make sure we don't have some module awake draining it. So here's how we're going to check it. You can see how high I have my meter set up. We're going to measure amperage. So we can measure up to 10 amps through here. After that, it's going to blow the internal fuse, because we're making this like a jumper wire. And so I'm going to disconnect the negative battery terminal, and I'm going to hook my meter leads up between the cable and the post, and that way we're completing the circuit between there and there, and we're going to measure all the current. Everything that's going through this battery is going to come through here. So once we do that, we don't want to turn on the headlights, we don't want to open doors or anything like that. One, we don't want to wake up any modules, but two, we don't want to put too much current through here and blow the fuse, and then I got to put a new fuse in this thing. And so I'll get it set up and then I'll show you. So there you can see I have the cable disconnected. It's not touching, it's only touching the plastic right here. So it's running through the red and then going through my meter and then back through this cable to the post. And so we're completing the connection. And you can see I have it set to measure milliamps. And so we're at 0.0324, so it's bouncing between 2 and 4, 0.04. So that's 40 milliamps right there is our max. It looks like we're getting up to. And so obviously we're bouncing around a little bit on our voltage. What we don't want to see is higher than 0.05. And so right there, if you let this car go a couple weeks at this, yeah, it's probably going to drain your battery, and I think that's what's going on. If you were driving this thing every day or every other day, you'd have no issues. And so this looks completely normal to me for a vehicle with this many modules on there like a Lexus has. And so I don't see any issues with that number. If we had, you know, up above 500, 600, or especially 100 milliamps like what a test light would use, or 150, that would definitely drain your battery, you know, within a day or two for sure. And so if it got up that high, we'd have an issue and we'd need to find out what the problem is. But from what I see right here, this is just fine. Alright, I reconnected the battery. How about we do the same test with a test light? You can see it, I hook up the test light to positive, and then when I hit ground, you see it lights up. This is just a standard run-of-the-mill test light from OTC. But now how about we want to measure how much current's going through there, so we'll put this in line just like we did our meter for the whole car. So we'll connect one end over here to the battery, and now you can see, now our meter's in line. You can see that we're connected because now our test light is lit up. I'll put it back over there and we'll see we're at 152, 153 milliamps. So that's the difference between what a test light, how much current it's pulling, and what this vehicle was doing right now with all modules off. And very important, once you're done measuring amperage, put your meter back the way it's supposed to be so we don't fry anything. And if you're curious why the milliamps were bouncing around when we were measuring for a parasitic draw, I believe the answer lies in our little security light right there. Hopefully you can see it flashing red right there. I believe that is changing our draw on the battery just a little bit every time it blinks, and that's what we were seeing down there. Alright, now I charged the battery, I got the vehicle going. How about a couple more checks just to confirm our diagnosis? So you can see I have my multimeter hooked up to battery ground. We'll just go to positive. We have no loads on there. You can see with a fully charged battery now we're outputting over 14 volts. Now we don't have any loads on there right now other than the car being on. Now we also want to go right to our battery terminal right there on the alternator, and you can see 14.10. So we got what, about 100 milliamp voltage drop. Let me check it again. So yeah, less than 100 milliamp, but 50 milliamp voltage drop. So there's nothing wrong with that. And then, so that we always want to make sure we don't have a voltage drop occurring between our terminal down there and our battery. That's why we want to make sure we're the same. And also, we want to check any voltage drop for our battery ground too, so we can keep it right where we're at. And we'll go to our alternator case down there. Just like I have it right to the case of the alternator. You can see 10 millivolts voltage drop on the ground. So nothing wrong with our ground either. And you can see, hopefully you can see, I got an amp clamp around our battery terminal coming off the alternator. It's been hovering between 17 and 19 amps. You can see right now we're about 18 amps. So this alternator is putting out pretty good with no load. Now we can do the same test with the load on it. Alright, let's do our same test with loads on the alternator. We got the high beams on, we got the blower on high. I could turn a few more things on too, but that'll be good enough for our test right now. We'll just go to battery positive. You can see we're at 13.8, hovering right there. We'll make sure we have the same down here. Very close. We got a slight voltage drop, but not enough to be concerned about. That's pretty normal. Putting out 14 there, and we're just a little bit under, about 200 milliamp voltage drop. Not the end of the world. I'd like to see it slightly better, but that's not terrible. And we'll do the same thing with our voltage drop on the ground. You can see slightly more of a voltage drop, but not much, nothing to be concerned about. You can see we're at like 57 amps, 58 amps. So this alternator is putting out a lot. And I turned the high beams off, so I still have the low beams on. I turned the blower off. You can see we dropped to about 37, 38. So the computer, or I should say the regulator in there, is definitely adjusting for our loads. So everything looks okay. Alright, as you can see with the loads back off, we're at 18 or so, 18 to 19 amps. And we can do a test right here. You can see we're back at 13.9. So we're good there. I don't see any issues. That's also a good check just to see the amperage change on our sensing circuit. Different vehicles have different ways of controlling the voltage regulator and controlling how much output. And some of them are computer controlled. Most modern ones are computer controlled. This one has a sensing circuit. So there's a wire coming over here to the battery, and it's sensing the circuitry that way, and it's using some logic to control how much output is coming out. So I think there's nothing wrong with that. We can do a couple more final checks and we're good. Alright, something else that can wreak havoc on our electrical system is AC. We don't want any AC ripple coming from that alternator coming over here to our battery and throughout our electrical system. A DC system like this, direct current, does not like alternating current. Now this thing is generating alternating current, and then it's converted to DC for our vehicle to use. So we want to make sure that our circuitry in there is getting rid of most of that AC ripple. So typically what we want to do, we're just going to measure between our battery post, or I'm sorry, our battery terminal on the alternator to a known good ground. And so I have it, my meter is grounded right there, and then I'm going to go to the alternator battery post like I was before, and we'll do our test. Now sometimes, this alternator is easy to get to. Sometimes these things are buried and you can't do it. You got to do it over here at the battery. It's not the end of the world if you do it that way, but you'll get the most accurate results if we pick a separate ground, a known good ground, and you can see that's a body ground that I'm attached to right there. And we can verify by checking our meter right there. You can see we're good right there. And so yeah, we want to use a good ground, and so it's a good idea to verify it. And then we want to go straight to the alternator if we can get to it. Like I said, sometimes I'll do the test right there. So we'll just take our meter, we'll turn it to alternating current, and now we'll just go right down to our battery terminal. And we want it to be less than 300 millivolts. You can see we're quite a bit less than that. We're at about 40 millivolts. Now typically, our best case scenario is we want to get this up to about 2,000 RPMs and make sure that it doesn't rise. I can't do that, hold the camera and do everything. So I'll clamp my meter on there and check that at 2,000 RPMs real quick and make sure we're not going too high. Now you probably can't see that, but at 2,000 RPMs, we're still at about 30 millivolts, 30 to 40 millivolts, so it's just fine. All right, seeing as we're here, how about a few more checks? You can see I'll back probe, we'll check the 3 wires on our connector here. And basically, if everything's working right, we're gonna have 12 volts of battery voltage on all 3. So I'm back probed on the white, I think that's a white with blue. So there's 1, then 2, and then 3. You can see we're at 13.56 volts, 13.6 volts. And if we go over to our wiring diagram, here's our alternator, also known as a generator. And you can see this B right there, that's our heavy duty battery cable, the one we've been working with. And then we have these 3 wires right here, 1, 2, and then 4 is how they're calling it. So the red one, we're gonna have ignition power. So as soon as you turn your ignition switch on, we're gonna have battery voltage on that one. And then the white with blue, which is what I'm back probed right now, that's our S, or our sensing circuit. So that's feeding back into our voltage regulator, basically telling it how it's doing. And then our L is our lamp. And typically, if everything's working correctly, it sends out 12 volts to our, in this case, engine control module, or basically engine computer. And then the engine computer, you can see, where is it? Here's another shot of our data lines coming from our engine computer, goes over to our combination meter, or basically our dash, and our charging indicator light, which we need to go look at, but our charging indicator light will come on if there's an issue with the battery. Old school systems, you would have battery voltage going into the light, and then this would be connected to this right here. And so when 12 volts comes out, it doesn't do anything, it doesn't light. If this voltage regulator senses an issue, it grounds that. And then, so now we're providing a ground for our light, and then our light will charge up. Now modern systems send it to the engine control module, same thing, it'll ground that circuit, but the engine computer senses that, and then the engine computer through data lines will turn it on. So that's all that is going on. So we can run through our 3 and make sure we have, system voltage. So basically the car's running, so we're going to have, like we just showed on the S wire, we're going to have 12.5 to 14. I'm sorry, 13.5 to 14, depending on how much our alternator is putting out right now. On each one of these wires, the ignition and this one's typically closer to 12.5, closer to where it should be on battery voltage. That's just how the regulator is putting it out. So we already tested that one, now we can do the other 2. All right, hopefully you can see I'm on the red wire now, and we got the same thing, 13.5 volts. So that's what the system's putting out right now. That's what our system is sensing, that's all it needs, so no problems with that. And then we'll check the last wire. Alright, now I'm on the, what is it, white with green? I believe it's white with green down there. It's the last final wire. You can see we're at 12.8, and so that's our lamp circuit. And so if that was grounded, then our lamp would be indicated or should come on. But in this case, we got 12 volts, so we're good. And to do all these checks, I just had my meter connected to battery ground over there, and then I was just probing with this little needle like that. I'm just very carefully going in between the insulation, and there's some weather seal on there. You can just go slip it right in between and touch the terminal inside there and get a reading. No damage done doing it this way. Alright, with our vehicle off, now I can talk a little easier. Some last final notes. We always want to make sure, of course, that our belt is, on all the pulleys. It's not misaligned, it's not bad, frayed. That belt looks perfect. Obviously, all of our connections, we want to make sure, this is good and tight down there. If it wasn't, we probably would have seen a voltage drop between there and there when we did our tests. So, and then I already mentioned, we want to see that these connections are all good and tight, so we can snap that back on. So those are all just general checks that you can do. You want to make sure, your system's good to go before we start firing parts at it. And another check that you should do, and I did this, but I didn't show it until now. I did this at the beginning. But we want to look for our battery light, which we were talking about. So that is coming from our L circuit, or our lamp circuit, right on our alternator. We want to make sure that when we turn the key on, it lights up. That's how it's supposed to be. And then because it's getting a ground, the computer has a ground signal coming over, and it's grounding that bulb. Now when we turn it on, that light should go out, and it should stay out, and you can see it is. So now there's 12 volts coming on that L circuit over the computer, and the computer is no longer grounding it. So our circuit, our bulb circuit is good, and it looks like our wiring and everything is good to go. And I told you I was slightly concerned about this Sirius XM setup. Well, I looked at it further, and there's a battery in there, and that's why it's able to stay awake. And then in looking how they powered it up, it's just plugged in through this outlet right here. So you can see I unplugged it and I put a little tester in, and that is switched with the ignition. So if you, can you look down under there? Ignition on, ignition off, ignition on, ignition off. So there's definitely no issues with this, and you can see it didn't even power up once I put the key in. So that's definitely out of the equation. I don't think there's anything wrong with this vehicle. Alright, there's a closer look at the tool I was using to measure the amperage coming out of the alternator. As far as specifications go for this vehicle from Toyota or Lexus, they say at 2,000 RPMs we should be seeing 10 amps or so, and at 2,000 RPMs with loads on our system, we should be seeing 30 amps or more. And just a reminder, anytime we're disconnecting or replacing a battery, or if the battery was completely dead, we need to normalize or initialize our control units, power window, moon roof, and usually there's a couple other things we have to do, as well as typically what I like to do is turn the vehicle on with no loads, leave everything off, and then let it idle for 5 to 10 minutes so that idle can start relearning. Most vehicles, that really helps them out. And you can see, according to service info, those are the systems that need to be initialized. You want to see one last final check? Sure, why not? We'll fire up our Foxwell again. You can see now we're hovering at 2.6, 2.7. There might be a little bit of surface charge on there. It might tell us we need to correct it. And we got a good battery. Now we're measured at 712 cold cranking amps, and as opposed to 700, which is rated for. I'll go ahead and do the starter and alternator test and come back with the results. Alright, we can go see the results here. There's our battery, more of our battery. See, we're state of charge now 100%. And you can see our cranking volts, it dips slightly lower than before, but it's not bad. That's not out of the norm. And then you can see our charging with no load and loaded. So this confirms what I believe. There's no issues right now. Alright, How about a few bonus pointers for those of you who stuck around to the end? Now, I went ahead and printed a screenshot from the video, and I know it might have been difficult to see what I was doing in there with this little amp clamp, but basically here's our main battery cable. That's the one going over to the battery from the alternator. What we want to see is what amperage this thing is putting out. So this amperage is coming from the alternator and going over to the battery, and that's how we're running our system and charging the battery up. And so what I was doing is I was putting this clamp around this battery cable right here. It was kind of difficult to see because I think I had to put it in like that. It was pretty tight in there. I couldn't just, I mean, from the picture here it looks like you could just stick it on like that, but you couldn't, or at least I couldn't see it. And so the way these things work is anytime we're running current or electricity through a wire, it's going to generate a magnetic field. So imagine rings around that wire. Once we have electricity going through it, there's going to be a magnetic field. And so this thing is just kind of reading that magnetic field, and it's doing some math to convert it to amps. That's all it's doing. Now these jaws have to be all the way shut. If they're like this, it's not going to work. So we always got to make sure we got it all the way around the wire. Now this thing, you know, it's pretty inexpensive and it's not, you know, super accurate, but for the work we're doing here, this works just fine. We're not sending this vehicle to the moon. So that's how it works, and it's important because we want to see that our, you know, alternator is generating, you know, current for our system to use. So that's why we definitely want to see what it's putting out. And another thing is voltage drops. We want to make sure our voltage is not dropping between that big heavy terminal right there and our battery. So looking at our wiring diagram, we want to make sure voltage is getting all the way back to our battery. And so that's why, you know, checking with a voltmeter is very important, because we want to see the voltage drops. Now, what is a voltage drop? We have to remember that, you know, a voltmeter is measuring the difference in potential. So it's the difference in potential here from here. And so basically, you know, if we put the leads on our battery like that, our difference in potential should be 0 and 12, which, you know, we'll just use 12 for easy math. So if we do that and everything's working properly, our meter's going to read 12. But like in the case of our charging lamp, on old school systems, we had 12 volts coming in to our lamp, and then typically this would be sending out 12 volts over to our lamp, and so we'd have 12 coming in and 12 here. So if we measured on our meter, we would have 12 on one side and 12 on the other. Well, that's what's this reading? It's reading the difference in potential. The difference in potential would be 0. 12 minus 12 is 0. And so that's where, you know, sometimes people get confused when we're doing voltage drops. And so we're doing the same thing, but now we're doing it, you know, from here to here. This should be putting out, you know, 14 volts or whatever. We'll just say 14 for easy math. And then 14 volts, we want to make sure it's reaching all the way over here. So we want to see what is the difference in what we're putting out here to here. And so when we're doing a voltage drop, we want these numbers to be as close to 0 as possible, because we don't want anything to change from here to here. So if we see a big change, we see, you know, 1, 2 volts or something like that, that means the difference in potential here is different from what's on our battery, and we don't want that. Now this vehicle checked out good. It was very, very low. Same thing with our ground. Now the alternator is grounded to the engine block. That's this symbol right here. And so what we're doing when we touch the case is grounded, so we can touch anywhere on the case. And then we go to our battery right here, and we want to make sure that that ground is getting all the way back here, and to our battery we also want to make sure that that voltage drop is 0. So the difference in potential here and here should be as close to 0 as possible. So that's what we're doing on those checks. I just wanted to kind of clarify that. As far as the other wiring is going, when we're doing our checks on those other 3 wires, we got 12 volts coming in. So when we do our check here and we have battery voltage, whatever the battery voltage is, same thing on this one, those lines are coming in. So when we're checking here, we know we've verified from here all the way out, all the way to our battery is good. This one, on the other hand, is that lamp signal is being sent out to the engine computer. So we verified that this is putting the 12 volts out, but we did not verify it over here. And so if we were having an issue with our charging lamp, we would have needed to check over here at our engine control module and see if our 12 volts was making it over there. Because if this line was broke anywhere, it's going to turn our charging light on, because this is going to think, hey, we need to turn this on, there's an issue. So we would have had to check there. Now, we didn't have an issue with the charging light, which is why I didn't need to go there, but just figured I'd point that out. Those are a few extra bonus tips for those of you who stuck around to the end. Well, as you saw, our voltmeter helped us diagnose and fix this one. And as always, if the video helped you out, you liked it, make sure to give it a thumbs up. Thanks for watching.